Okay, so like it says on the tin, we're going to talk about everything to do with the Northern Lights. Have you ever seen them? They were quite visible in the UK earlier this year. I've never seen them. I've never been lucky enough. I tried going to Finland once, and yeah, they weren't there. But let's talk about everything there is to do with the science behind the Northern Lights. So, the big one, what causes the Northern Lights or the aurora? So, it basically comes down to one simple thing of the sun's magnetic field is weird. So, I've got a diagram here. If you've ever seen a bar magnet in like a field of iron filings, you can see the magnetic field lines. So this is literally, what causes a magnet to be magnetic. If something comes into this magnetic field line that's magnetic, it'll get attracted to it. The same is true for planets and also for stars. So planets are very simple for the most part. They're very similar to a bar magnet. So they'll have a north pole, a south pole, and you can see these lines kind of coming off of it. The sun has the same thing, but it's a bit more complicated. So whereas the Earth is solid, so when the Earth spins round, the magnetic field will spin round with it. The sun, is best to think of it as like a big ball of liquid. So when it spins, the middle spins much faster than the top and the bottom. So what happens is you have these nice clear field lines of the magnet. What happens is they kind of get all knotted and tangled up, and then that's what causes issues. So eventually what will happen is, so we can see on the left one in yellow, this is the sun's magnetic field. We can see it literally coming out. What will happen is they will twist and get tangled up as the sun is moving around, and they will get into knots, and eventually they will break. When they break, it's called a coronal mass ejection, and this is because it's material being ejected out of the corona, which is an area of the sun. This sends particles out into space, and when these particles hit our atmosphere, they cause the aurora that we see. And we'll talk a bit more about this in a minute, about how the sun can affect how often we see the aurora. So you can get these really cool things. Sometimes you can see these with telescopes. So these are much bigger than the Earth, probably. These are huge. So why don't we see the aurora all the time? So we can't see them in the day. The sun's just too bright, even though the sun causes them. Like things like we can't see the stars during the day. The sun is just too bright. Clouds, they're a bit of a pain. You can't see the aurora through the clouds. It also depends on what's going on with the sun. So I'll go into a bit more detail on that in just a second. So the other thing as well is it's easier to see the aurora at the poles. So it really depends on where you live. So the particles from the sun are magnetic, and they get attracted to the north and south poles. So what you see is you tend to see the northern lights within the Arctic Circle, and you tend to see the southern lights within the Antarctic Circle. One thing you might note is you tend to hear more mention of the northern lights than the southern lights. And that's just because there's more people living where the northern lights happen. So the northern lights generally tend to happen, as I said, in the Arctic Circle, and there's just more land there, whereas in the Antarctic Circle, you tend to see a lot more ocean, so there's just a lot less people living there, so it just doesn't happen as much. But things like there has been sightings of aurora in Australia, the bottom of Africa, and South America, so it does happen there too. Okay, so I kind of alluded to this just now. The sun isn't the same all the time. So the sun goes through a cycle every 11 years when the sun is more active and then less active. So we've got a graph here that's kind of showing how active the sun is. So when the sun's really active, it gets these things called sunspots, and these are just little black dots on the sun. The more active it is, the more of these spots it gets. So you can see kind of about every 11 years, you get these peaks of, where the sun activity gets very high. At the moment, in 2024, we are at what's called a solar maximum. So this is when the energy of the sun is very, very high. So that's why this year we've had 2 sightings of the aurora in the UK, when normally they're not seen this far south. So we are in cycle 25, which is just off the edge of this this graph here. So we've only seen 25 cycles of the sun happen, since we've been recording. So that's not that many cycles when you think about it. The other thing as well, as you might notice here, is it looks like there's another trend of where the energy's getting, the numbers getting higher over the decades, and then peaks in about 1960, and it's coming back down again. There are some theories that there are other cycles to the sun that actually goes through these like 80-year cycles as well. But the issue is we've just not been looking at the sun long enough to try and see these patterns. So, because let's say there is one of these cycles every 80 years, that would be 8 normal sun cycles. And yeah, we've only seen 25 of them, so that'd be 4 of these bigger cycles. So we still don't really understand the sun very well. So I should add as well, so when you're so solar maximum is when it's really easy to see it, solar minimum is when it's really hard to see the northern lights. So in about 5 years time, there'll be almost like no aurora, and it'll come back again in about 11 years time. So it's kind of up and down. So what's the difference between aurora and northern lights? They're the same thing, pretty much. So we got aurora borealis is the proper name for the northern lights in Latin. These are near the North Pole. They're pretty displays in the sky, and as I mentioned before, they tend to be seen more often just because there's more people and more land in the area of the Arctic Circle. Because the Arctic Circle comes down to about the top of like Finland, Norway, Sweden, all through Canada and Russia. So there's a lot of land there. You then also have the aurora australis, which is the southern lights. So these are near the South Pole. They're pretty displays in the lights in the sky, so very similar, and as I mentioned, just seen less often. But they tend to both be called aurora, or again, you tend to mention the northern lights. We're not special. We're not the only planet that gets aurora. So any planet with an atmosphere, so air, and a magnetic field can get aurora. It has to have both of these things. So we've got a picture here of Jupiter's aurora. You can see it's like this nice blue color, and so this is much, much bigger than the Earth, these aurora. So it would be pretty cool to see if you're on Jupiter. Other planets that potentially get aurora, so we know Saturn gets aurora, so we can see it here on the top of Saturn. Uranus on the right gets aurora. So the weird thing with Uranus is because it's sideways, it would actually be like to the west and the east that you get these aurora. Yeah, Uranus is weird. You can see it here in red. It's kind of a fake color just to make it a bit clearer, because the aurora on Uranus tend to be blue as well, but you wouldn't be able to see it very well with the blue planet. The ones we're not sure about is Mars and Venus. So Mars doesn't have a magnetic field as far as we know. We think it has a very weak magnetic field, but nothing like what the Earth has. It's quite a small one. And also has very little atmosphere. But since we've been sending rovers and stuff to Mars, we think there's been little pockets of aurora kind of popping up on Mars, but it's still something that's unknown. The other one is Venus. So we're not 100% sure if Venus gets aurora. We think it does, because it is it has a magnetic field, it has an atmosphere. But again, the issue with Venus is you wouldn't be able to see it from the surface, you'd only be able to see it from space. But again, we think there are aurora happening there, but I don't think there's any like photos or anything of them yet. What do the different colours mean? So you might have noticed that aurora change colours. This depends on how much energy the particles from the sun have and which gases the particle hit when they come into the atmosphere. So I've got different colours here. So we start in the bottom left. We've got blue and purple. These are caused by nitrogen. So when the particles come, they hit nitrogen atoms in the atmosphere. Green is caused by oxygen. And then red is caused by oxygen, but this is oxygen higher up in the atmosphere. The other thing as well is in this order I've put them in from left to right is how much energy the particles need to have. So blue and purple is the less energy particles, red is the highest energy, and then also in the same order is how common they are to least common. So blue and purple are the most common, green is kind of medium, red is the least common, and you will also can get orange, but that's quite rare. Again, you need the sun to be really active for that to happen. So of course the big question is, when will the next aurora be? The answer is no one knows. Aurora is weather, we call it space weather, and just like Earth weather, it is really unpredictable. You cannot really predict it. So if you want to go visit somewhere to try and see the aurora, there is no guarantee that it will happen while you're there. Again, you can try and like hedge your bets by going going during a solar maximum, going when the weather's clear, going to the Arctic or Antarctic Circle. Those will increase your chances, but there is no guarantee. There's no guarantee it's going to be sunny tomorrow or it's going to be rainy tomorrow. So yeah, unfortunately, it's very unpredictable. That's kind of a quick overview of everything to do with the aurora and northern lights and southern lights. Thanks for watching. I hope you enjoyed it. If you want to see some other weird things that happen in space, maybe you're interested in hearing about how time changes in space depending on how fast you're moving. This is one of Einstein's biggest discoveries. So yeah, hopefully see you in the next video.